the world's first biological computer. So what that actually means is we put live living biological neurons in our system to do the computation for us. Because these have electrical activity, we read their electrical activity and we're able to stimulate information back in by these electrical pulses. So then with this closed loop system, we're able to do the computation for us. So we've shown very early on in our systems is they're able to learn and embody these in environments. So we're able to show that the video game Pong. So this is a good example here of these electrical pulses that is happening. So then we're able to also stimulate information in. Just if you watch this electrode and we stimulate, you can see that there's pulses that come through. Just in the corner there. So because these are also live living biological systems, we also have a life support system for these neurons. So what we have is a gas mixer. So you can think of it like our lungs. So we've got to oxygenate the media and provide it CO2 to control the pH of the media. And also these neurons will produce waste products. So what we have to do is filter out that waste. So the way we do that is we create these two filters, which acting like a kidney to filter out wastes. And then we also have our stomachs and our bladder to control the waste. And then every 2 to 3 weeks, we extract out waste products.
How do you? What is your vision? What are the next steps on the journey of this kind of project? When we will have it, I think in labs or in a more mainstream environment.
Yeah, that's a great question. So at the moment, we have a collaboration with the University of Barcelona. So they've been using our systems and they've been culturing their own neurons out of their cultures, and they've been putting it in our system to do the research that they want to do. So we've got that stream, but there's also a cloud platform that developers can use, which allows them to do the applications that they want to do, while we look after all the biological systems and the systems. So some of the first early applications that we're looking at is drug discovery and personalized medicine.
Personal medicine. Okay.
So what we do with personalized medicine is because we can extract blood from patients, say if they have epilepsy or other neurological diseases. So from that blood, we're able to turn them into stem cells. And then from stem cells, turn them into neurons. So these neuron cultures will exhibit the same properties as the patient themselves. So then with these cultures, we put them in our system, and then they'll exhibit, obviously, the epileptic features, properties, and then we can apply drugs to them. So if we have parallel or multiple systems with these cultures, we're able to do parallel drug testing. So it allows us to do drug testing without the patient being involved, but it also allows us to look at side effects that typical drugs these could do, is like brain fog and concentration.
And there's no tracks on using this for computations. It's really more for testing biological stuff, but not having some using neurons for computation. And it's another topic, so it's something about that.
Yeah, so more of a future application is 5 to 10 years time is actually going to be looking into autonomy and robotics for our systems, because these systems are very power efficient and data efficient,
Yeah.
as opposed to AI systems. So that's where we can really see this getting advancing, is that if they're very data efficient, they're very good at navigating 3D spaces.
Yeah.
Just like small insects. They're
So I was asking that because we are in a world where we try to do something faster and faster. Quantum computing is interesting because we're doing lots of things in parallel,
yeah,
and we see that human body is very efficient. And with
Exactly.
our neurons, we can do a lot of things for very few power.
Yeah, exactly.
For me, it was a kind of way to compete with quantum computing to maybe do it better with some part of human computation.
Yeah. So because obviously biological systems are very power efficient.
Yeah.
So the human brain uses about 20 watts of power per day. So and they're always constantly learning as well. So that's a good thing with our product, is that if we get them into robotics and autonomy systems, they're very good at navigating 3D spaces, image recognition, all those sorts of things.
And what are the next steps? Is like, what is your target? It's like 2030, you will 2026. What are the next steps in terms of agenda?
Yeah, so we have no real target for those applications. So we're just 5 to 10 years time. But what we're really doing is creating a platform for developers to experiment and use our system to see how far they can push our system and this type of technology.
Okay. Thank you.
No worries.
Yeah,